again today to talk about steel. If any of you have seen the previous videos and liked them, please consider hitting that little button right here. It's that little MMI button. That's our subscribe button. Please consider hitting that and subscribing. If you are new, and this is your first video, thank you for tuning in. If you're back, well, thanks for tuning back in also. We appreciate it. We're super grateful for all you watching. If you happen to enjoy the video, please consider dropping a little thumbs up and like it. Or if you have any questions, please make sure to drop a comment in there and I will do my best to get those answered. But if you could, just subscribe. That's easiest. This video is our second part on the pH stainless steels. And if you haven't seen the first one, maybe you should go do that now. That'd be great. So you either have seen the first video covering the basics, or you decided that you know all that stuff already, and so let's move on. Regardless, if you're watching this now, you do have the basics of martensitic pH grades covered. Now our next type is called semi-austenitic. Chemical composition of these alloys lead to a different set of structures during the steps of heat treatment. Like all pH stainless, the first step is a solution treatment. That achieves the uniform distribution of the elements involved in the hardening reaction in an austenitic structure. On cooling from solution temperature, the structure of these alloys remains austenitic at room temperatures, but only temporarily. This relatively soft and ductile austenitic structure gives us the opportunity for much more extensive fabrication prior to hardening than martensitic types permit. Well, it looks like we found a way to have our cake and eat it too. We can have a softer and more formable metal at this stage, and then we can later harden to the high strengths of the fully martensitic pH grades. To achieve the final hardening of the material, we need to first make the austenitic structure able to transform to a martensitic structure. Sounds easy enough. 3 methods can be used to permit the martensite structure to form. Either sub-zero cooling to temperatures on the order of minus 100 degrees Fahrenheit and holding for up to 8 hours, or heating to about 1400 degrees Fahrenheit and holding for up to 3 hours, or lastly, cold work, like cold rolling sheet. Now that we have a martensitic structure, our familiar aging treatments are able to do the final hardening in these types. The combined 2-step process of hardening these grades is indicated by a letter prefix plus the H followed by the aging temperature. The prefix indicates the method of forming martensite. For example, RH950 indicates a sub-zero refrigeration, hence the R, followed by the aging, the H, at 950 degrees Fahrenheit. TH1050 would indicate the thermal method, followed by aging at 1050 degrees Fahrenheit. CH900 indicates cold work, followed by aging at 900 degrees Fahrenheit. Common examples of semi-austenitic grades are 17.7, which is AISI 631, 15.7, which is 632, AM350, which is 633, and AM355, which is AISI 634. Applications often require the premium cleanliness of remelted steel, and the precise details of the required heat treatments vary by grade and specification. Our last type of pH stainless steels are those that retain an austenitic structure from solution treatment through aging. Although much lower strength than the other 2 pH types, they are non-magnetic and higher strength than the 300 series stainless steels. Solution treatment is typically at higher temperatures than the other types. Aging is also at higher temperatures of 1300 degrees and above. Most often, only a single aging treatment applies to the alloy. With higher aging temperature, these alloys find use at temperatures where the other pH types would lose strength. As an example of this type is grade A286 with premium vacuum remelted cleanliness for aerospace engine or turbine applications. As always, we close with a caution about the critical importance of specifications. In these complex materials, check the spec. But for instance, I just mentioned a grade A286, and regarding the caution that surround the specs, this alloy is a perfect example. There are literally five different types just based on round bar of A286 specs. There are 5 different types with all kinds of specs. There is an age-hardened solution treated to 1650 degrees Fahrenheit to an AMS 5737. There's an age-hardened solution treated to 1850 degrees per AMS 5732, which supersedes AMS 5735. There's a regular solution treated to an AMS 5731, which supersedes AMS 5736. Then there's 2 cold reduced types, one at 160 KSI, to many different AMS specs. Some I've already listed above, and ones I didn't are AMS 5734, AMS 5736, and AMS 5853. And then there's the other cold reduced at 210 KSI, which meets AMS 5726, as well as other previously mentioned AMS specs. So, as you can see, the specs will literally make or break your application. Never, ever underestimate how utterly important the specifications are, and always make sure that you are getting what you know you need to get. Check the spec. Next up in our series on stainless steels will be the 2 higher strength types, duplex and manganese substituted austenitic types. So, I hope you enjoyed this video, and stay tuned because next week we got that one on the manganese substituted austenitic and the duplex. But just remember, if you've made it this far, please consider subscribing. Click here. Now, if you want to catch up on some of the previous videos that you may have missed, or just loved them so much you need to watch them again, click here. That would be great. So, please consider hitting that subscribe button. This is Michael with Michelin Metals. I hope you enjoyed it. Have a great day.